Okay, hello everyone. Thank you. Welcome to the seventh video for this series. We're going to be talking about implicit differentiation. Okay, implicit differentiation today. All right. This is very easy. I'm going to just show you one of my tricks I use quickly to solve this question. So for instance, let's say we have y is equal to, let's say, x squared plus 2x plus 1. It's very simple. So that means to get the value of y, you just know the x is completely, let me say, defined, or sorry, y is completely defined in terms of x. So that means if you know x, it can give you y straight up. But if you have, so this is what we call an explicit. So that means it's explicit, straight up, it's open, it's easy to see. But when you have y, let's say we have, let's say xy plus, let's say cos y is equal to 5. So you can see that you cannot really define y completely in terms of x. So this is what we call implicit, okay? Implicit. All right. So now in this kind of what we are doing now, we're trying to differentiate implicit equations and see what we can do. So I have a rule that you just need to keep in mind. All right. When doing this, the first one, differentiate. All right. So what you do, you differentiate x normally. Number two, you differentiate y as well, but you add dy over dx to it, okay? And number three, you make the y dx subject of the formula, okay? You make the y over the x subject of formula, all right? All right, so very good. You'll get x, you differentiate x normally, but when you get to y, you differentiate y, or then get to y, you differentiate y, add the y dx, and after that, you make the y dx into the formula. So let me give an example here, okay? So let's say, let me pick an example. I have x squared plus y squared is equal to 25, all right? So I'm going to differentiate x squared. It's going to give me 2x normally. I come here to differentiate y squared. It's going to give me 2y. But remember, when differentiating y, you add what? The y over dx. And when you differentiate 25, it's going to give you 0. So we make the y dx of the formula. You take 2x to the other side, and that'll give you 2y. The y over dx is equal to minus 2x. Then divide both sides by 2y. So that means the y over dx is going to give you minus 2x divided by 2y. And this will give you minus x over y, dy over dx. Simple, straight up, you're done. Okay. Let's take another example. Let's see another one I have here. So I have number 2. I have y equal to x squared plus, sorry, not y equal to, I have x squared plus y squared minus 2x minus 6y plus 5 is equal to 0. Okay, so the same thing. I differentiate x squared, it's going to give me 2x. I differentiate y squared, it's going to give me 2y, y over dx. I differentiate minus 2x, it's going to give me minus 2. And I differentiate minus 6y. I think I have the wrong question. Yeah, I think yeah, it's correct. So I have minus 6y, is going to give me minus 6 the y over what? Dx. I differentiate this, is going to give me what? 0. Okay, so I collect the like terms. So I take 2x and minus 2 to the other side. So I'm going to have 2y dy over dx minus 6 dy over dx is equal to, I'm going to have 2, take minus 2 to the side comes 2. You take 2x to the other side, it comes minus 2x. You collect like terms, so you have the y over dx is 2y minus 6 is equal to 2 minus 2x. So we now have the y over dx is equal to 2 minus 2x divided by 2y minus 6. I can simplify this further. 2 is common, and I have 1 minus x divided by 2 will give me y minus 3. And this will cancel this out, and I will have 1 minus x divided by y minus 3. And that will give me the answer I'm looking for. So dy over dx is going to be equal to 1 minus x, y minus 3. Very good. Let's pick one more question on this. I usually like solving 3 questions of 2 different types so that we can give you an understanding of how to play around with implicit differentiation. So we have another question here. We have x squared plus 2xy plus 3y squared is equal to 4. Okay. So you can see in this implicit differentiation, we're going to play with 2 rules here. We're going to play with the implicit differentiation, and we're going to play as well with product rule. So if you see here, we have, if you differentiate this, we're going to give it 2x plus. Now, if you want to differentiate, because we're having 2 functions, we're having both the x and y in the variables here, or in 2 variables here. So you keep x constant and differentiate y, and you keep y constant and differentiate x, and you add them together. Remember the product rule. So remember we had the product rule. We said uv is going to give you u prime v plus v prime u. So you keep v constant, differentiate u, plus you keep u constant, differentiated v, and you added them together. So we'll keep x constant, okay, differentiate y. So that is going to give you 2x y over what? Dx. Then plus, then you keep y constant, differentiate that, and that is going to give you 2y. Plus, then you do this, it's going to give you 6y, dy over what? Dx is equal to 4. Next thing, you collect like terms, okay? So let's collect like terms. So it's going to become 2x dy over dx plus 6y dy over dx is equal to, sorry, this is going to give you 0 because when you differentiate 4 is 0. You take 2x to the other side, it's going to give you minus 2x. You take 2y to the other side, it's going to give you minus 2y. You collect like terms, so x is going to be equal to 2x plus 6y is equal to minus 2x minus 2y. So dy over dx, divide both sides by 2x plus 6y, and that will give you minus 2x minus 2y divided by 2x plus 6y. You can collect like terms. You have minus 2, and you have x plus the y divided by 2 into bracket x plus 3. This will cancel this. So it's going to give you minus x plus y divided by x plus 3. And that will be the answer for that. Okay. All right. So just here, for those that did not watch my video on product rule, okay, please go back and watch the video on product rule. And here, just remember that because we're having 2 variables together, x and y, you keep one constant, you differentiate the other, and you add one and keep the other one constant. So basically, just to reiterate, so we have 2xy. So I'm going to keep 2y constant, and I'm going to differentiate x. And the next one, I'm going to keep 2x constant, and I'm going to differentiate y. So that's why I'm going to have, because I'm keeping y constant, and it's going to be 2y. Okay, differentiate x is going to give you 1. You keep 2x constant, but because I'm differentiating y, I put the y dx. So please just don't forget, that's the only difference here. With that, that will bring me to the end for this session, okay? And this is just for the implicit differentiation. So the rule, just to quickly remind you about the rule, you differentiate x normally first, but when you're differentiating y, you add the y dx, and you make the y dx subject of the formula. That's all. All right, thank you very much. And the next video, I'm going to talk about parametric differentiation. And I think that will be the last video for the series. Then the next, after that, I'm going to start a new series on further integration. We'll talk about integration by parts, integration by substitution. And I'll see you in the next video. And please don't forget to like and subscribe, so you can get notification when I upload.